My second paper critic, we'll be doing the paper of NoDB, which is a way to do query execution and data analysis over raw data files. So basically, we'll just go right into it and see what it is all about. So, what exactly is the paper about? So, if you look at let's say your traditional databases, you will have what you will know is there in the form of rows and columns and all those things. But your actual data will be in CSV file or some other file format. So basically, what this paper is all about, it's processing with an tool that can directly do data analysis over the raw data instead of you actually sitting and loading them. And this particular topic is not something that's new in the sense, because I personally have worked with such files. I've worked with them in Oracle. So in Oracle, you have external files which basically do the same. And I have just attached another link of how it would look like. So in this sense, okay, just a little bit here. You can see that in the temp directory, they're placing all these raw data files in which they're doing it. And also, Oracle is pretty good known for such things. And it's not only Oracle that is there, but there are other vendors which do the same, such as MySQL and few more. So Apache and even Google have their own implementation. So what is different about this is there are many problems that come with external files, and they try to cover these problems. So the main problem is the performance penalty that you are using a non-optimized storage structure. You're trying to access it. So we are working around that. So what problem that they're trying to solve is that it's the same. So basically, they're trying to uh, do data analysis on large data sets without actually sitting and loading them into the data set. So let's say you want to analyze over two columns, but when you try to load the database, you will have to load the entire database to just get those two columns. So you will have to do a lot of manual steps to do an analysis. So this method actually cuts down all these things. And what they also try to do is they keep the performance at the maximum. So compared to all the other previous examples which are provided, so they try to keep the performance at maximum. Okay, so um, what are the key findings of the paper? Yeah, so the findings are that the NoDB solution turns out to be very good and it's very fast. Okay, I've attached an image showing how good it is. So if you look here in the image, you can see that uh, CSV engine, Postgres, and all take a lot of time. And if you look at their implementation of Postgres raw, it comes down to be the least. And yeah, so anything that is highlighted in these slash color, it is the time taken to loading. So you don't see a time to load in this. You can directly go to your queries and start working on it. And what are the main contributions of this paper are it is one of the final solutions that is actually usable, and you don't have to worry too much about indexing and other things which actually give you performance, because in this case they have other workarounds to go about it, and you don't have to sit and make use of all those loading and column like loading certain column just to get one column worth of analysis. You can do it on the fly so that you can go about it, and also you can enable statistics and you can see how better you can optimize your queries. So this paper is built upon some prior works. So their fundamental idea is that they have leveraged CoFi. So it is a index advisor. So basically, it will tell what to keep in the index so that our files can effectively point to it and you can get data. So their main USP point is this. And also it is built more on Oracle external files, MySQL files, Apache. So all these are implementations that leverage external file concepts, and they also take the advantages of traditional DBMS. So how does this paper differentiate from these frameworks? Yeah, so basically what they've done is they've taken the best of two parts. So they've taken the advantages of having external files, and also they have taken the conventional databases and they've just merged them together. So that is how they have differentiated from others. So how did they evaluate their proposal? So if you look at it, so they've used the server, and on the server they have for the following specifications. I'm not going to read too much into it. Just that they've used an SSC at RAID 0, and they've used a data set of 11 gigs, and it has 150 attributes, and the data set was TCPH. I don't know where I've written, but anyways, yeah, it's here. So TCPH, TPCH benchmark was done, and they benchmarked it against conventional databases such as PostgreSQL and DBMSX. And they switched on two parameters that they have. So they have two optimization parameters such as position mapping and caching. They switched it on to review the performance. And what methods were used in this paper? If you look at it, so they took synthetic and real-world data sets to do the benchmark against all the candidates, and basically they put it in a plot to show how good the performance is compared to others. And also, they showed the impact when you switch on each feature that it has. So they've shown individually the two features that it has to show how good it is. Okay. So before we deep dive into the comparison, let's look at few of their parameters that they enable. So their main USP is that they have two things. So they have an adaptive positional map. And what this basically does is, since it is a file and we don't have the concept of index, so what they're basically doing is, let's say the data is first getting loaded onto the system. So what it does is it creates a map of where the tuples are, and based on what kind of data is coming in and going out, these tuples, the pointers to these tuples get changed here and there. So that's how they know where exactly to point it. So they'll have a tuple range of 50 and they'll play around with it. And they also have caching. Caching is not something new, and they have LRU based caching. So anything that is not used too much will be discarded. So if you look here, just give me one second. Yeah. So if you look here, initially the cache usage will be 0, and as the data gets loaded, it keeps on increasing, and after a certain point, here the cache will be fully utilized, and it will just take in new data and swap out old data. So if you look here, this is the baseline Postgres raw, their NoDB solution. And if you look at this, it is their solution with so these triangle ones. This is the solution with all the parameters enabled. Okay. And as I said before, these are the conventional databases, these two. And TVMSX is pretty fast, and but still it's not as fast enough as this because it spends a lot of time on data loading. And also, Postgres Raw allows you to do statistics generation. So with that, you can better form your queries and all. So if you look at the performance when you enable statistics, is your queries will perform in around the same range. But if you enable statistics, you will see a significant drop in the actual time taken to execute. So they have done many things that are very nice. So if you look at it, they have created a new system that works more upon solving the existing flaws that the original systems had. And that is something good because we don't often see people trying to challenge conventional databases because they're so prevalent in the system. And they've also shown that the system is actually viable in terms of cost and performance because it really runs very fast. And yeah, in the end, it is very convenient for us because it again boils down to giving the feature that, hey, I just want to analyze 2 to 3 columns of data, but I don't want to sit and load 150 columns worth of data into a database just to get analysis on two things. So, some aspects in the paper the author did not develop well. So, some of them would be the databases that they've used, such as Postgres or DBMSX, are the only two examples that they've used. So, we don't see how it would actually turn out against many other databases. And also the paper itself. So, if you look at the paper, I've had to read two papers of their implementation, and in none of them they talk about the shortcomings or the limitations of the paper. So really, I don't know how good or bad it actually is. And if you look more into it, there are other similar vendors. So Apache itself has something called as Drill, which is almost similar. So we don't know the comparison against it. So that is something they could have done. And one last thing that I couldn't figure out much is their actual implementation because they've put up a image of it in their other implementation paper, but we don't actually get to see how the actual implementation is. So we can't talk more about how to improve it from an implementation standpoint. So what I could have done differently is, in the research itself, I could have compared it against my direct competitors to know how good or bad my solution actually is, so that I can put forth with more concrete evidence that, hey, my solution is much more better than the current vendors. And what I could have done more is that I could have taken some other data sets, a large different varieties of data sets, and see how the performance is with respect to those. And what else I could have done is, so the thing is, they have kept the position mapping at 50 and caching and other things. So we don't see the cost of those things itself. So we don't see where and how those things can be improved. So that is something I could have worked upon. And yeah, so basically take all these things and find out the shortcomings and work on those shortcomings basically. Is there anything that needs additional justification? Yeah. So this paper works off of external files. So they could have gone more into the hardware part of it because they could have changed the hardware and they could have potentially gotten better performance, most likely. And they use a very structured columnar data set such as CSV. They should try other data so that we can see how good or bad the performance will turn out to be. So, what other experiments would I suggest? So, basically, I would change the current SSD, the SATA SSD that they've used to NVMe SSD to see what happens. We could also use a GPU to see what happens. Also, we could scale it much better to see what basically happens. And then I can see like if I enable a query optimizer, what would happen. And I would also put all these things against the our direct competitors. Some ideas that I want to explore is I want to see in real life how actually viable it is, and what is the impact of latency in terms of time or cost and all those things. And I will try with different complex queries to see if complex queries will take a hit on it. And yeah, so this application has a lot of real world application. I mean, basically, it can be used anywhere where data analysis is done and it saves on time. So its applications are boundless in essence. So yeah, so that's about it. So thank you so much.